Alright, for review 3 we're going to look at some of the problems from Module 7, which dealt with our conic sections, our circles, and our ellipses, and parabolas, and hyperbolas. So the first thing that we're going to do is go back and look at the distance formula and midpoint formula, which are our first two things that we learned in that section. So if you remember, the distance between 2 points is given by a formula. Distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared as well. So really we just subtract the x's, subtract the y's, and take the square root. So in this case, our distance between our 2 points, d, will equal the square root, so we'll take negative 2 minus 6 squared plus negative 5 minus 5 squared. So negative 2 minus 6 is negative 8 squared, and negative 5 minus 5 is negative 10 squared. So the distance between these 2 points is going to be the square root of 64 plus 100, which is going to equal the square root of 164. Now if we want to try to simplify this radical, I know 164 is 4 and 41. This is 2 and 2. 41 is prime, so we basically have a group of 2's with a 41 left over. So this is going to be 2 times the square root of 41. So that is the distance between those 2 points on the coordinate plane. Now the second problem talks about what's the midpoint between the 2 points. And again, another very simple formula for that. It's actually a point, and we find the point by adding the x's and dividing by 2, and then adding the y's and dividing by 2, because we're just trying to find the middle. So in our problem here, we're essentially adding the two x's, which in this case would be negative 2 plus 6 divided by 2, and negative 5 plus 5 divided by 2. Well, negative 2 plus 6 is 4, so we get 4 over 2. Negative 5 plus 5 is 0 over 2, so we get 2 comma 0. So if we were to plot those 2 points in the coordinate plane, put a line segment between them, this would be the middle point. The distance would be the one that we found in part A. Okay, question 2 says identify the center and radius of the circle whose equation is x plus 3 squared plus y minus 7 squared equals 25. Now if you recall the generic equation for a circle, x minus h squared plus y minus k squared equals r squared, where the center is hk, and then of course the radius is r. So if we look at this, the number at the end is 25, so that is r squared, so the radius is the square root of that, so the radius is simply 5. Now the center is even easier, because we're just going to take the opposite of the numbers that appear in the parentheses. So the center of this circle will be the opposite of 3, which is negative 3, and the opposite of negative 7, which is positive 7. So this circle would have a center of negative 3, 7, and a radius of 5. Okay, question 3 says write the equation of an ellipse with a center of 2, negative 5, one vertex at 8, negative 5, and one foci at 6, negative 5. So if we graph these kind of points to kind of get an idea of what we're doing here, we have a center of 2, negative 5. 1, 2, 3, 4, 5. So here's our center right there. We have one vertex at 8, negative 5. So that would be over here at 8, negative 5. So there's a vertex. and one foci at 6, -5. So any axis that contains the vertex is going to be our major axis, so our ellipse will go something like this. So what that tells me is when I write the equation, I want the bigger number under the x, because the bigger, longer axis is going to be the x-axis in this case. Now, I also know some different numbers because we have this a, b, and c, don't forget. A is how far it is from the center to the vertex. So how far is it from 2 to 8? Well, that would be 6, so A is 6. B is from the center to the co-vertex, which I really don't know what that point is. But C is the distance from the center to the focus. So from 2 to 6, that's 4 units. We don't know B, but we can find it. Because recall, we know B squared equals A squared minus C squared. So we'll just plug in to find B. So A squared would be 36, 6 times 6, minus C squared, which is 16, 4 times 4. So B squared is 20. So B is the square root of 20. So now we have A, B, and C, which is our distances from our vertex, our focus, and our co-vertices in this case. So now if I want to write the equation, I'm going to make sure the bigger number A comes under the x-axis because it's longer that direction. And it contains the vertex. I'm going to make sure that the smaller number b goes under y, and it is b squared. And of course this equals 1. So a squared is going to be 36, and b squared is the square root of 20 squared, which is 20. So the only thing left to do is change my center. Remember my center is 2, -5. So I take it the opposite of each of those in my ellipse equation. So this is the equation of ellipse that has that center, that vertex, and that focus. Okay, question 4 is a very similar kind of problem. It says states the coordinates of the foci of the ellipse given by the equation x squared over 16 plus y squared over 4 equal 1. Now, there's nothing inside the x squared or the y squared, so I know the center is 0, 0. That'll help me. So if I kind of draw my ellipse 0, 0. Now, the bigger number is in front of under the x, so I know it's going to be longer left and right, just like the last one was. And I know a squared is 16, so a is going to be 4. B squared is 4, so b is going to be 2. So the question is, we really need to find C, and since our ellipse goes this way, we'll really just be going in that direction to find our foci. So we will use the exact same equation we used on the last problem, which is b squared equals a squared minus c squared. We just have different things in this case. So b squared is going to be 4, a squared is going to be 16, minus c squared. So I'll subtract 16 from both sides. I get -12 equals negative c squared, which both can become positive. So when I square root it, c is the square root of 12. Now that c is important because we know our focus is that distance from the center. And since it's 0, 0, you're basically taking 0 plus this number. So our foci are going to be square root of 12, comma 0, negative square root of 12, comma 0. And you can, of course, simplify that radical. I probably should have done that. It would be 2 square root of 3. Alright, the next one says we want to graph the parabola x plus 5 equals 12, y minus 4 squared. State the coordinates of the vertex and the focus. Well, first of all, I see the square in this case is on the y. Now, with the square being on the y, that means we have a parabola that's going to open to the left or right. So it's going to be one of these two things. Since it's positive, the 12 is positive, we know it's going to open to the right. So we'll just write that. It opens right. Now the vertex we can find just by taking the opposite of the numbers that are with x and y. So the vertex is going to be -5 and +4. So -5 and +4 is right here. There's your vertex. Now the way we find the focus is we know that this number is 4a, because if we know the generic form of the equation for a parabola opening to the right, it's x minus h equals 4a times y minus k squared. So a is the distance from the vertex to the focus. So in this case, since it's 12, 4a equals 12, so a is going to equal 3. So that means we go 3 units along the axis from the vertex to find the focus. 1, 2, 3, that will take us right here, because this distance here is 3. So our focus, if I just look what that point is, that's -2 and +4. So our focus will be -2, +4. And so I know the parabola opens to the right, so something like this. We could find more points, or you could, of course, just graph it, see a generic picture of what it looks like. But the most important thing is to know how to find this vertex, taking the opposite of x and y, and how to find this focus just simply by counting from the vertex. Let's look at our last one here. It says, what are the asymptotes of the hyperbola x squared over y, or over 4, pardon me, minus y squared over 25 equal 1? Now the equations of a hyperbola are always y equals plus or minus something x. If the x comes first, which it does in this case, it's a over b. If the y came first, then it would be b over a. So we know this is a squared, and we know this is b squared. So a is the square root of 4, which is 2. B is the square root of 25, which is 5. So our asymptotes would simply be y equals plus or minus 2 over 5x. So very simple to find the asymptotes. And what we could do with that, if I wanted to, is if I plot this on a graph, so we're going up 2 over 5. So we have an asymptote that looks like this, and then down 2 over 5, and this is centered at the origin, obviously. So those are my two asymptotes, and knowing a is 2, and under the x-axis I could put a point at 2, and then my hyperbola will go this way, kind of along the axis. And it would start here and it would go right along the axis this way. So having those asymptotes of the hyperbola really makes it really easy to graph it as well. That's really the whole main purpose why we find those asymptotes. Okay, so that is all for review 3. Please let me know if you have any questions.